Welcome back again to the PLC Professor's Workshop. This is my location where I record videos and lectures discussing lab projects. I have another location that lends itself better to lectures that are conceptual. They're just technology. So what are we doing here? Well, the last lecture was really part one of the virtual machine, and we went through and we programmed it with latches. And because we latched everything as we went, once conditions were met, we latched a bit that basically said that that step is done. So if this bit is on, then in the next rung, the first instruction says that step's done, now let's do the next step. The problem is because we leave everything latched, you can't bring another part into the system until you clear all those latches. So in this next discussion, that's what we're going to do. We're going to kind of go along behind ourselves and unlatch the latch conditions once they're no longer relevant, so we can kind of clear the spaces occupied by parts as it goes through the system. Now, this project, you'll find it in a number of manuals. This is the current one that we're working with, this set. And you recognize it by the vertical red and black, not horizontal like the previous collegiate version. Now, all the manuals that you might have from me on RSLogix 5000 are going to have this lab project in it. Occasionally we go through and we add a few things, add some features or something to our virtual machine. So let's continue on. This is part 2, and then we're going to pause when we're done with this, and then the next lecture will be part 3, the final section for this lab project. Let's do it. Virtual machine part 2, more parts. In the last video we kind of got to the end where we had run one part completely through the system, and it had moved on downstream out of this station to the next station, and the finished product conveyor was running or was not running. In order to get the system clear to accept another part off the feed conveyor, we had to get rid of that one part and get the conveyor stopped. That would reset all the bits. Now keep in mind, you could have edited the logic to do something different. And at this point in your learning process, you're free to go out on your own and experiment and make it your own process. The next phase in our manual, we're still working with the same virtual machine, and we had gone through and latched the station 1 complete bits, the step bits. However, with them all latched up, we were not able to bring another part into the system unless we completely finished and rinsed out the entire station downstream on the finished product conveyor. So now we're going to go back and kind of unlatch bits behind us as we go. So I'll go up to the top here. I'm back up at the top of the program, rung 0. I also paused and downloaded and put the controller into the remote run mode. At this point, it's not necessary for me to run the program while I'm recording. Mainly what I want to do is discuss the logic, discuss the changes that we made. Now, once again, I will remind you that the best way to write a sequence program like this is to use CLN logic, not to use latch and unlatch. However, most of you listening to this video, if not all, will have to troubleshoot other people's code that did use this style of programming. So it's good to see the entire gambit of programming styles. Now, I'm not showing you all of them. I'm not doing state logic. There's just a lot of things I'm not doing. But this is more than enough to get you started, because it's all about analyzing code. Even if you just want to program, you don't want to troubleshoot, the best way to learn how to program is looking at programs that work and seeing how they did it, and then pretty soon you develop your own taste and feel for how you want to write programs. At this point, we're going to unlatch the station step complete bits once we're through with them. So if we look here, we see that in rung 0, nothing's changed there. If the part number is greater than 5,000, and of course you see that it's not, and if I went to the barcode reader, you see that if I do a barcode trigger, it will be greater than 5,000. So this rung is not changed. However, notice in this rung, if step 1 is complete, we clear out the part number so we can accept a new part number from the barcode reader. And when the scanned part reaches photo I2, because its scanned part number was greater than 5,000, we're going to extend cylinder 1 and cylinder 2. Once cylinder 1 and cylinder 2 are extended, we latch up step 2, saying step 2 is complete. Now we no longer need this bit latched, so we unlatch it. Just that simple. And you can see in this rung, nothing to speak of has changed. We could take out this instruction, because once step 13 is done, we unlatch once step 3 is latched, we can unlatch step 2, which we latched up here. Come down here and step 3 is complete, and we are going to retract cylinder 4 and latch up step 4. Now we're going to unlatch step 3. So this all within one program scan. We no longer need this instruction to prevent latching up step 3 again, because we unlatch 2 right here. So once this rung is true all the way through, meaning that step 2 was complete, step 3 was not complete, the drill motor is running. 3 seconds later, we extend cylinder 4 to bore a hole in that part. We say step 3 is done. We unlatch step 2. That alone prevents this rung from running again. So I'm going to go ahead and delete that out of there. Whether I had you do that in the manual or not, I don't remember. I'm looking at the manual and I see that's still in there. Doesn't need to be in there. Now, it didn't hurt anything. It's just wasted space and wasted use of memory. So you can see here step 3 was complete. We've extended cylinder 4. We wait a little delay. Then we retract cylinder 4 and we say step 4 is done, and then we unlatch step 3. Step 4 is complete, and if cylinder 4 is retracted, then we turn off the drill motor. We retract cylinder 1 and cylinder 2. We say step 5 is complete, and we unlatch step 4. At this instant in time, and remember, this all doesn't happen in one program scan. Here we unlatch the bit, that output bit, that caused cylinder 4 to extend. Whether in the real world with a real cylinder, 1 or 2 seconds that it takes to retract to make this prox here in rung 4, or the timers that we're using in our cylinders program, it's the same thing. This program will have scanned through thousands of times between you unlatching this bit, the program unlatching this bit, and this retracted prox being made. These aren't happening, this rung executes, this all happens, and then this rung is immediately going to be true. It won't be. It'll be a couple seconds before this instruction is true. Okay, so we turn off the drill motor and we retract cylinder 1 and cylinder 2. We say step 5 is done and we unlatch 4. So if we just keep scrolling down through here, you'll see the same pattern. And again, because we're unlatching bit 5 here, it can't go back through and execute this rung again because this instruction will be false. So I'll just delete that out of there. And remember, neither one of these things that we remove are hurting anything. It's just kind of cleaning up. The reason you don't want to leave stuff like that behind is because someone else who's troubleshooting your program, they've got enough on their hands reading your program. That doesn't mean your program's bad, but they didn't write it, so they're not familiar with it like you are. And if they see those two instructions that we deleted, they're going to be wondering, now, I wonder why that's in there. And even though it's obvious that they can't do anything, they can't hurt or help, it's going to kind of hold them up a little bit, trying to figure out why those instructions are in there. So that's kind of like cleaning up your mess behind you as you go through and you edit the logic. It's good not to leave like that stuff in there. I'm going to widen this out a little bit. That way we don't have it wrapped around. Again, 6 is completed. We latch a bit saying there is a part at cylinder 3 extend. That's a virtual sensor. And then we retract cylinder 3 in this 1 second delay here between the cylinder 3 being extended and us retracting cylinder 3. That's to make sure that the cylinder is fully extended. Because remember, the adjustment of that sensor, if it's not in the right place, the sensor could say the cylinder is extended when it's really not completely extended. Now, it would have to be very poorly adjusted in its position to be so bad that it would prevent the piston from going to the end of stroke or the rod from going to a hard stop, which is end of stroke. We say step 7 is done and we unlatch the bit for step 6. Same thing here, 7 is done. We turn on the finished product conveyor, we say step 8 is done, and we undo 7, which we latched up here. Same thing. Now this is a little bit different here. We added this in between the last video and this one. We added it in the manual, and that was, when do we unlatch this bit that said that there was a part at cylinder 3 extend. So we said there was a part here at cylinder 3 extend when the cylinder was fully extended. And step 6 wouldn't be complete unless the rungs above had actually pushed a part into this position. So we declare a part there, we retract cylinder 3. Well, there's only one way that that part can no longer be at the end of stroke of cylinder 3, and that is if you grab it off the conveyor with your mitts, your hands, or the finished product conveyor runs and moves it off of that position. So what we're saying here is, if the finished product conveyor is running when photo I3 is blocked, then we unlatch that bit. Now the reason that the finished product conveyor examine on bit is here, instead of saying, oh, we could say if photo I3 is blocked and the finished product conveyor is running, then unlatch that bit. However, we want to be much more precise than that. And remember, with a one-shot instruction, whatever's on this side, on the right side of the one-shot instruction, has to be true when this instruction goes true. Otherwise, it won't execute this instruction. If this goes true and then the next scan this goes true, it won't unlatch that bit. Precisely at the moment when photo I3, its optical path is blocked by that part, if the finished product conveyor is running, all that says is that the part is moving into the photo eye. That way, because it's moving into the photo eye, we know that it was pulled away from the end of stroke of cylinder 3. So we unlatched that bit. Now these two bits right here, or this bit right here, part at cylinder 3 extend, is a virtual sensor. Continuing on down, so we didn't unlatch anything here but that virtual sensor. So this was kind of in between step 8 and step 9, and really it can happen at any time. So it's really thrown in here because it could happen at this point in the sequence, but it really doesn't matter. This rung could be down at the end of the program, it's still going to function correctly. So step 8 is done, and now we get into our, do we have a downstream call or don't we have a downstream call? But all we're doing here is adding the unlatch for step 8 when we latch up step 9. Same thing here. When we latch up 10, we unlatch 9. When we latch 11, we unlatch 10. We latch 12, we unlatch 11. We latch 13, we unlatch 12. And that's all there is to it. So now what we've done is we've gone behind ourselves with each step and unlatched the previous step. So it is now in a position, it's in a state that it can accept more parts. One thing that I am not doing at this point, I'm not going through the manual and reading off all the questions that had a fill in the blank, but I am answering those questions in my discussion on this logic. If you want to check the questions in your blanks, listen closely to the video and then go back and see if you put in an appropriate remark for those fill in the blanks. Another change that we made in the program, continuing on in the manual, was called More Memory Locations That Remember Events. When we were only running one part through the system, it didn't matter to us where that part was, because it simply had to completely leave the whole station on the finished product conveyor and turn off the downstream call before you could even put a new part in there to clear the bits. But now that we're clearing the bits, step 1, step 2, step 3, and so forth, we need to know if there's a part at these different locations in the system. So we already did a part at end of stroke for cylinder 3 or part at cylinder 3 extend. We also need to know if there's a part at cylinder 2 extend, because let's say that we want to stop a part in front of stop number 2. In other words, cylinder 5 is extended, there's a part sitting in front of photo I3. Well, the finished product conveyor at the end of stroke for cylinder 3 it's empty. So we could process a part and push it out end of stroke cylinder 3 onto the finished product conveyor. And that leaves that spot open to push another part off of the feed conveyor into the machining area to bore a hole in another part. But we can't do that if there's already a part there. So we create another virtual sensor, part at cylinder 2 extend. We don't allow cylinder 1 and cylinder 2 to extend if there's a part at cylinder 2 extend. And of course, to know there's a part at cylinder 2 extend, we actually have to set this bit at some point. They're both right here. So if photo I2 sees a part on the feed conveyor and there's no part at cylinder 2 extend, then we can extend cylinder 1 and 2 and push a part off of the feed conveyor into the process area. However, if there is a part, then this will be false and we won't extend cylinder 1 and cylinder 2. And what will happen to that part? It'll go right on down the feed conveyor and off into who knows where. We are examining a bit that we don't set until later in the process. So if we extend cylinder 1 and cylinder 2, we can extend them if there's a part there. So if there is no part there and we extend them, in other words, we latch this bit and then a couple seconds later these two sensors are made. So we say, okay, there's a part at cylinder 2 extend. We know because we just pushed one in there because we saw it at photo I2. There was not already one there, so there is one there now. So that's where we set part at cylinder 2 extend. And somewhere we have to unlatch this bit to say there's no longer a part at cylinder 2 extend. Well, how would it leave that spot? End of stroke for cylinder 2. Well, cylinder 3. When it extends, it's going to push it out of that spot and out onto the finished product conveyor. If we scroll down, we're looking to unlatch the part at cylinder 2 end of stroke. So here we retract cylinder 1 and 2. That part that was at cylinder 2 is now here. See, we latched this bit, so we could unlatch this bit now. We could actually probably unlatch it right here. However, I added a separate rung. So these rungs that declare that the part's no longer at these virtual sensors, they're together. If the cylinder 3 extend proc switch is made, we one-shot and unlatch that bit. Now the one-shot may not be necessary, it's just a habit of mine when you're looking at an event, because a one-shot instruction puts a sharp point on the event, a sharp edge. So that's primarily all that we've done in our logic that was different than the last step in the manual. Now these are the type of things that may or may not appear right away when you're commissioning a system. Remember that you're out on the shop floor, whether it's at the machine builder or at the end user, and you're testing your logic and you're running the machine through its paces to see if everything works correctly. And what if there was no part at cylinder 2 at one point, but there was at another? So to kind of tidy up or put a real sharp edge on all this, you see here in rung 1, we're saying that if step 1 is complete and photo I2 sees that part, then and there's already part at cylinder 2 extend, then we unlatch step 1. So if we unlatch step 1 right here, then this is not going to be true, and we're not going to extend cylinder 1, cylinder 2. So again, that's going to allow that part that should have been pushed in there to go on down the trail. Now, out on the shop floor in the real world, you would probably add more components to the system. In other words, you would figure out some way to buffer these parts upstream before it got this far, so it only released one at a time onto the feed conveyor when the system was ready to accept it. And you could simply do that by adding another conveyor upstream from the feed conveyor in your diagram, before the parts even get in the system, that has a stop on it. Or they're just buffered on that conveyor. In other words, you move one on, the photo eye sees it, it stops. You move one on, the photo eye sees it, you stop. And then at some point that buffer conveyor is full, now it's backing up, all the way back up to the previous station or the previous part of the process that we haven't talked about. We don't even know what it is upstream. So in this case, we're letting the parts go on by if we can't handle them. So this rung 1 right here, this is new. And basically, if photo I2 sees the part and the part number was greater than 5,000, then it unlatches step 1. Now that does beg the question that if we unlatch step 1, then we should also clear the part number. I did not have that in the manual, and I see that we should probably add that because, oh wait a minute, no. There's enough time delay in here. So this is how you're thinking when you're doing these things. So this latched, okay, and there were seconds at least before it got to this photo eye. So this rung would have been scanned. With step 1 set, it would have cleared the part number immediately. So we're good. We don't need to add a clear up here where we unlatch. But this is the way you got to look at things. In the next section of the manual, we switch over to seal-in logic from latch-unlatch. So instead of setting a bit to 1 when a step is complete and then clearing it on some following step, we're going to switch over to seal-in logic where there are really no steps. It's just logic that does not require an indication of what step you're in. In other words, each rung is somewhat independent of all the other rungs. So you could even jumble, move around the rungs in a different order and it would still run okay. Seal-in logic is, and you know this from volume 1 where you did latch and then you did seal-in logic, that everything that controls that output bit, whether to set it or clear it, is all in one rung. Easier to troubleshoot, a little bit more difficult to write. So let's start here with our first rung. When we see a part, in other words, photo I1 sees a part, we generate a barcode trigger, and that still operates that subroutine the same way and it returns a part number. And if that part number is greater than 5,000, then we latched up station 1. We've broken this into 2 rungs, one for the barcode reader trigger, and the second one to determine whether or not we have a part that we want to process. Now, in the previous logic, latching station 1.1, in other words, saying step 1 is complete, was the same thing as saying a part just went through photo I1, it was scanned, we want that part into the station to bore a hole in it. New part queued for station 1 was station 1.1 bit latch before. So if you look at our 2 replacement rungs, if we see a part in photo I1 and the barcode trigger pulse is done and we don't have a new part queued in already, in other words, if we've already got one going on down the conveyor there, we don't want to queue in a second one. In other words, we want to prevent a second one from thinking, the system thinking it's going to grab a second one. So if there's no new part queued for station 1, then we generate the barcode trigger pulse. Okay? If the barcode trigger pulse is done, in other words, if barcode trigger pulse timer is done, then this rung goes false. Because not done is in the second place there on this rung. Barcode trigger pulse dot done, true if off. Okay, so you see this logic is a little bit more complex than the previous. And we also are clearing the part number within this new pair of rungs. So if the part number is greater than 5,000, then we turn on a bit saying that there's a new part queued at station 1. Now, that's going to stay there as long as the first part of this rung is true. Of the pair of rungs here, the first one is more traditional looking. You have 2 true-if-ons or together, true if off, enable a timer, and then turn on the barcode trigger bit. Technically, if this was full conventional programming, barcode trigger set that bit would have been in parallel with the timer. Now, what's keeping that barcode trigger bit on is the timer timing pulse all the way back at the beginning of this rung. So you see, this logic is a little bit more complex than the top rung there, which was really straightforward and simple. The problem is, and I've said this many times in this course, it's easy to write programs using latch bits. But when you do that, then you got to unlatch the whole world. You got to go back and unlatch them at the right time. Whereas here, these 2 new rungs, they're self-sufficient. They're sufficient within themselves. So the object of the first replacement rung there is the barcode trigger. It's going to be on for 3 seconds. The second rung, if the part number that was scanned in by the barcode is greater than 5,000, it says there's a new part queued. So it's coming on down the feed conveyor. Okay, now we have a situation here where once we say there's a new part queued, there's got to be a life to that status or state. So we're using 10 seconds. We're saying if the timer new part timeout, if it times out, it's done, it's going to clear the part number. And what are the consequences? If we clear this part number, this is no longer true. And if the timer times out, then this is no longer true. In other words, this is true if off done bit. So if it's not done, but if this is done, this goes false, this is false, so we drop the new part queued bit. So we give it a life of 10 seconds. It doesn't have to be 10 seconds. I just grabbed that out of the air. It depends on your process. Not only did we replace that first rung with 2 rungs, we added a level of complexity into these 2 new rungs that didn't exist before, because without using latch bits, we have to be a little bit more clever in how we prevent things from happening that we don't want to happen. The next rung that we need to replace is if station 1.1, step 1 was complete, we want to clear the part number. Now we've already cleared the part number in one case where the life of that queue timed out, but we still have to clear the part number if we bring the part into the station. Looking at the two replacement rungs, in the first one, if we have a new part queued and it hits photo I2, in other words it blocks the optical path, we're going to clear the part number at that point. And if we don't already have a part at cylinder 2 extend, then we're going to extend cylinder 1 and cylinder 2. And if we turn on the bit, the output bit 0 there, to extend cylinder 1 and cylinder 2, and the boring operation has not been completed, and you're thinking, what in the world is that? Boring operation completed. Well, that's a bit that gets turned on further down in the process when you've completed a boring operation, and you'll see why this bit needs to be here. So again, doing sealing logic is a little bit more convoluted. Now, in your course of writing this program, if you run your own, you might have had cylinder 1, cylinder 2 extend solenoid, seal in and hold cylinder 1 and cylinder 2 extended. In that case, it would stay extended if we didn't have something that interrupts the true out condition from our seal-in branch that goes around those 4 instructions on the top. So what's going to cause cylinder 1 and cylinder 2 to retract, in other words, it's going to cause us to the false execution of that OTE there to local 1 O data 0, what's going to cause it to go to 0 and then allow cylinder 1 and cylinder 2 to retract is when the boring operation is completed. Now think about it. We've got cylinder 2 and 1, but cylinder 2 specifically holding the part in the V block, and we're boring a hole in the part. Once that process is complete, well then we can retract cylinder 1 and 2. Real simple. So actually when I wrote this, I created that tag, boring operation completed, and put a true if off instruction to drop cylinder 1 and 2 extend solenoid before I actually had any logic that turned on the boring operation completed. Because logically I knew in my mind, when do I want cylinder 1 and 2 to retract? I want it to retract once the boring operation is completed. In other words, you bored a hole in the part and cylinder 4 is fully retracted. So everything's clear. The boring operation is then completed and we can retract cylinder 1, cylinder 2. Okay, and the part at cylinder 2 extend, we're not latching and unlatching now. So we have to take and move all of that logic into one rung. So look at that second replacement rung. If cylinder 1 and 2 are extended, which they can't be unless there was a part at photo I2. So we set a bit then, part at cylinder 2 extend. It's the same bit we had before, we're just not latching it. If we have a part at cylinder 2, then we seal in cylinder 1 and cylinder 2, because think about it. If we use the extended proxies on cylinder 1 and 2 to say there's a part there, well, what happens when we retract cylinder 1 and cylinder 2? The part's still there until cylinder 3 pushes it out of the way. So look at what we have to interrupt part at cylinder 2 extend. We seal it in with itself, but we use the cylinder 3 extended proc switch not being on to keep that part at cylinder 2 extend bit set. So until the cylinder 3 extends and hits its procs, we're saying there's still a part at cylinder 2. Actually, it's quite logical. Once you start thinking this way, you'll get comfortable with it. It's not as quick and easy as latching, and probably somewhere out there, there's still a machine or two that's got some of my latched up programs in it. Do I wish I could go back and change them? Not really. Probably nobody knows I did it. But in a career doing this, you're going to leave programs behind you that don't represent where you're at today. Okay, so that's replacing that rung. Here's a couple more rungs to convert. These are much simpler, and I've actually have two here. I have existing rung, replacement rung, existing rung, replacement rung. So let's take the first existing rung. And if you look close, you'll see that there's not a whole lot of change other than we're saying that if cylinder 2 is extended, then let's turn on the drill motor. And then we have a delay of 3 seconds when it's done. And we're not saying to retract cylinder 4, then extend cylinder 4. You're probably thinking, well, why would you have that in there? Well, you'll see later on that we needed the not retract cylinder 4 to drop out the extend cylinder 4 solenoid. So pretty straightforward. And you also might be thinking, so if cylinder 2 is extended, then the drill motor's on. Yeah. Cylinder 2 extends, pushes the part in there. When it hits the extend prox, it's time to turn the drill motor on. And the drill motor is going to stay on even after cylinder 4 retracts. We still want the drill motor on because its spinning acts like a centrifugal fan, and it actually cools the bit quicker if it's spinning than if it's not spinning. Forced convection. Anyway, so that's real straightforward. But we did introduce a new bit. So in looking at that, when I wrote this, I had to say to myself, okay, I'm turning on the extend solenoid for cylinder 4. How am I going to turn it off? Well, I'm going to turn it off when I tell it to retract. So I just threw that bit in there, retract cylinder 4, true if off, and then worried about the logic to actually do that later on. What you see is in the next replacement rung. It's not far away. So in the next replacement rung, and you look at the rung right above it, station 3, 1, bit 3 was on, which means step 3 was complete. Cylinder 4 is extended, so true if on, cylinder 4, extend, proc switch. We start a 3-second delay, and that could be a 1-second delay. I think in some places in the manual I had 1 second, other place I had 3 seconds. It really doesn't matter, it's just a little delay there. And that is to say that it's fully extended. Now we want to make sure that we extended cylinder 4 all the way. And for two reasons. One, we want to make sure it fully extended and not did a short drill operation because the prox on the cylinder was in the wrong position. Plus we wanted the bit to continue to spin fully inserted in the part to remove as much debris as possible from the hole that it bored. Okay, then we unlatched cylinder 4 and we said step 4 was complete and we unlatched step 3. That's all been replaced by, and if you look, you see the very first instruction reading left to right, top down, cylinder 4 is extended, the proc switch. We have the same delay, and then at the end of the delay, instead of unlatching cylinder 4, we're just turning on the retract cylinder 4. So if you go up into the first replacement rung, you'll see that this is how we retract cylinder 4. Now we use the retract cylinder 4 bit on to seal in retract cylinder 4 until the cylinder 4 retracted proc switch is made, meaning cylinder 4 is fully retracted. So we tell it to retract cylinder 4 until it's fully retracted, and it drops out the retract cylinder 4 bit. Real straightforward. A couple more rungs now, and you look at that first existing rung and you see that there are 4 latch and unlatch instructions. So we're unlatching the drill motor. Now you remember we already took care of the drill motor in a previous rung. If cylinder 2 is not extended, then the drill motor goes off. And we don't need to unlatch cylinder 1 and cylinder 2. It's already taken care of. And we're not latching bits for station steps or unlatching them. So all that's left is cylinder 4 retracted procs. And remember when we had the boring operation completed, and I told you when cylinder 4 is retracted, the boring operation is completed. And so we one-shot that bit. Now that bit being one-shotted, it's only going to be on for one program scan. It's going to drop out that rung up above that this was assisting keeping it sealed in. Perfect shot, perfect example of a good use for a one-shot. Now you, I suppose, could say that the boring operation is completed as long as cylinder 4 is retracted. The problem is that may interfere with a future operation because the last one is completed, but if you're using that bit in a way that prevents the next one, then you got a problem. So we one-shot it. Then the next rung, you have 3 latch-unlatch instructions. We want to extend cylinder 3 and then set bit 6 and clear bit 5. So you can kiss the last 2 goodbye quickly because we're not doing that anymore. So now we have to control cylinder 3. So let's look at the logic, the replacement rung. If there is a part at cylinder 2 extend and cylinder 2 is retracted and there is no part at cylinder 3, then we want to extend no part at cylinder 3 extend position into stroke. Then we want to extend cylinder 3 to push that part out there. Okay, so if we have a part at cylinder 2 extend and cylinder 2 has cleared and it's out of the way, and there's not already one out at the end of stroke on cylinder 3 on the finished product conveyor, then we extend cylinder 3. That is held in by its own memory location and until the delay retract cylinder 3 timer is timed out. Now, would you think of all of this right at this point? Maybe, maybe not. But we have to have some way of unlatching, or I'm sorry, we have to have some way of unsealing the branch around that holds cylinder 3 extend solenoid at 1 and extended. If it's energized, local 1.0 data 1, and we haven't done a delay retract cylinder 3, then it stays extended. That's simple. Now we're going to do a 3-for-1. So we've got one rung up there, and keep in mind that this is not a direct translation. If you have learned any foreign languages, whether English is a foreign language to you or some other language, I've been learning Spanish for a number of years, and there's no direct translation for many words from one language to another. The idea can be translated, the idea in your head, what you're thinking, seeing, feeling, that can be translated, but it's not a one-for-one translation. So you'll see that in some cases here we have to include things that aren't in the existing rung. So let's look at this existing rung. In this existing rung, we declared that there was a part at cylinder 3 extend position. Then after a delay, we retracted cylinder 3 and then cleared some step 7 done, cleared step 6, and so forth. So the last 2 instructions in that existing rung, they're gone right off the bat. So let's look at the rest. Cylinder 3 extend proc switch starts a delay. It just starts a timer. And as long as cylinder 3 extend proc switch is made or on, energized, then the enable is going to stay on for that timer. Delay, retract, cylinder 3. However, there's a 1-second delay before the done bit comes on. So we look at the next rung. If cylinder 3 extend solenoid has been turned off and the cylinder 3 retracted switch is not made, meaning it's not retracted, and the cylinder 3 extend switch is not. Now, you're probably looking at that and saying, well, wait a minute. How can neither one of them be energized? Think about it. In what condition would neither sensor at the end of stroke of a cylinder sense the piston? Obviously, if the piston's somewhere in the middle, right? Now, we know that cylinder 3 was extended, and now we want it to retract. So if we are looking at cylinder 3 extend solenoid, and I'm talking about this first instruction right here. If we're looking at that, if it goes off, then we're retracting. If both of these are true, then it is retracting. It's not extended or retracted, it's retracting. It's actually in motion. So this bit will come on when cylinder 3 is retracting. Then this bit along with this bit, no part at cylinder 3 extend, is going to keep this on until this is interrupted right here. So this is sealing logic. So let's look at the next rung. When photo I3, and you should recognize this logic, it's not really changed. When photo I3 sees a part, when the finished product conveyor is already running, then this goes on for one program scan. This goes false and drops out part at cylinder 3 extend. So it works the same way that it did before. Couple more rungs here. Well, and one rung, existing rung and a replacement rung. So the goal was to turn on the finished product conveyor in the existing rung. And you look at the conditions, ignoring step 8 and step 7 and all that. Cylinder 3 retracted proc switch. Well, we want cylinder 3 to be retracted anytime the finished product conveyor runs. That we know it's not pushing something out or had just pushed something out on the conveyor. So if cylinder 3 is retracted and photo I3 does not see a part, and cylinder 5 is retracted or not extended, whichever way, you could use a true if off extend procs there, but it's more positive, deterministic to use the true if on retracted proc switch, then turn on the finished product conveyor. So look right below it. If cylinder 3 retracted proc switch is made or sensed, and there is a part at cylinder 3, we don't want to turn on the finished product conveyor unless there's a part there, or if there's a downstream call. So if there is a part at cylinder 3 extend and photo I3 is not already blocked, then we turn on the finished product conveyor, and basically whatever turns off the part at cylinder 3 extend would stop the finished product conveyor or when it hits photo I3. However, if there's a downstream call, we production-wise, process-wise, decided that if there's a downstream call, we'll just turn on the finished product conveyor and leave it on. Now, the only thing that will interrupt that, if you look close here, is cylinder 3 retracted proc switch. Downstream call on, that bypasses the two conditions above it. So if cylinder 3 is not retracted, in other words, if cylinder 3 extends to push a part out onto the conveyor, that's going to go false, the conveyor will shut off, and then it pushes it out. When it's fully retracted again, conveyor goes right back on. So the finished product conveyor will pause anytime cylinder 3 is not retracted. Real straightforward. This is where it got a little messy in doing a one-for-one translation. And you know, you can read the text. It says, now that we have the finished product conveyor running, which takes away the finished product, we can tidy up the tail end of the sequence. The following 9 rungs can either be eliminated and or replaced with the 2 rungs directly below them. So if we go down to the 2 rungs directly below them, we're replacing all of this up here because none of this matters anymore. It's already all been combined into the other logic. So all that we have left here is cylinder 5 because we didn't deal with cylinder 5. So when do we want cylinder 5 extended? If there's a part at photo I3, we say there's a part at photo I3, turns on that bit for use for other things, further up in the program. And if there's no downstream call, then we turn on cylinder 5. We need all this because these 2 right here could be broken out into a separate rung. I probably should have done that. Maybe you noticed that. This could be a separate rung. Says if photo I3 is blocked, then there's a part at photo I3. Irrespective of anything else, there's a part there. Now, if there's now no downstream call, then we turn on cylinder 5. Then I decided later, if there's no downstream call, well, energize cylinder 5. So we still need this if this is used, part at photo I3. If it's used elsewhere in the logic, then we still need this logic. But that could be in a separate rung, and we could eliminate this instruction right here. We're going to leave it there because that's the way it is in the manual, but I'm just telling you right now that you could probably delete this because this overrides this. So whether this is true or false, it doesn't matter, because if this is true, true if off, no downstream call, it's extended. Here's a slightly different variation of that same rung. This is actually what I had in my finished project. If photo I3 sees a part, it says there's a part at photo I3. And if there's no downstream call, then it extends cylinder 5. This logic works as well. So you see it gets a little untidy on the bottom edges of it. This rung right here is kind of like a poor man's HMI, MMI, screen, operator screen. You're looking at new part queued for station 1, part at cylinder 2 extend, part at cylinder 3 extend, part at photo I3. This is so you can see 4 parts in the system at one time. And a no-op is a no operation, meaning it doesn't do anything. So this is just here to look at. So you can watch these 4 bits and you can see the part moving through the system. You notice also that we tidied up our reset. This is what we had we have a reset button and we clear the virtual output data. That's all we do. We no longer have step complete bits to clear. Okay, we're going to finish this off right here. This video really is longer than what I like, but I couldn't see breaking it up right in the middle. Hopefully you paused, made note of where you're at, and came back and finished watching it later.